Hello, everyone. I'm sorry that I have to be gone again today. Hopefully, it's only a few more times this fall. I think maybe like once or twice. Uh, However, I recorded the lesson so you can hear me discuss it, the topics that we're going to be talking about. If you would please start by having out yesterday's homework assignment. I'm just going to read off what the answers are to that, and then I will check both this one and today's when I am back. So, 2.5's homework assignment. Question number 5, the answers were 4, -2, 7, -6, -2, 9. 7 and 9 we did in class. 9 was a no solution because it's the absolute value equal to a negative number. Number 11 was a little bit of a challenge. If you look at the picture, the center point is the number 1, and each of the endpoints are 3 away from it. So if you translate, you would say the distance from 1 is 3, and that's where the math equation comes in. 17 is 8.4, 23 is -11 and -9, 27 is again no solution because the absolute value equal the negative number. 31, 11% to 19%, 41 no solution, 48 5A, 47 to 53 is your range, and 45B, a sample answer, as the speedometer was calibrated more accurately than the speedometer for part A. Those are your answers to 2.5. If you would please now have out your note packet to 2.6 and 2.7. Today's notes will take 2 pages, mostly just because some of the pictures are a little bit bigger. It's our last section in our chapter 1 and 2 review of topics. Make sure that you have your boot camp form done by Thursday when the test is going to be. And okay, let's start. So the very first part for today is a vocab word. The word is the word ratio. A ratio uses division to compare two quantities. So one more time, a ratio uses division to compare two quantities. Example might be if you're comparing cups of flour, 2 cups of sugar in a baking recipe, or miles, 2 gallons if you're measuring what your car's gas mileage was. There are 3 ways to write a ratio. The first one is to just use English. You say A to B. Second one uses what we call a colon, A colon B, and it's A with 2 dots, B. It's read A to B. And the last and most frequently used is a fraction or division symbol, and we write A over B, but all of them are read as A to B. That's what a ratio is. When we set one ratio equal to another ratio, we call that a proportion. A proportion is an equation that states 2 ratios are equal to one another. Examples are shown in the ones below that we're going to work. So that's what ratio and a proportion are. Example, how do I solve with proportions? So here's an example of one. I have y to 4 is equal to 15 to 20. Here are 2 very simple strategies. Strategy number 1 is you look for a pattern. The pattern that I see here is how do I get from 20 to 4? Well, I divide by 5. Because these things are in proportion, the pattern must hold up top, so it must be 15 divided by 5, and that means that y is equal to 3. And then I'll see that 3/4 is equal to 15 over 20, so y is equal to 3 is my answer. That's strategy number 1, is find a pattern. Strategy number 2 is to just solve as if it were an equation. Over here I see y is being divided by 4. How do I undo dividing by 4? Well, I simply multiply by 4 on each side. If I multiply by 4, these will cancel out. On the right-hand side, I'm going to get 15 times 4 is equal to 60. I get 60 divided by 20, and I get 3. I get the same answer as I did a second ago. I just did it using a different strategy, which was solve. So 2 strategies so far. I can pick out a pattern, or I can solve. Okay? There's one more strategy that we're going to use, and that is mostly in a case where the variable is going to be on bottom. It will always work, but it's more helpful in other situations than in others. So example, what if we had one that looked like this? Do either of our prior strategies work? Well, if I try and look, how can I easily get from 12 to 8? Well, I can't using multiplication and division. You might think subtraction, but subtraction wouldn't work. 12 to 8 is -4, so if I did that for here, I'd get to 11, and you can check that 8 divided by 11 does not equal 12 over 15. So I can't use subtraction or addition. These have to be multiply patterns or divide. So I can't look for a pattern, and if I try to solve, my variable's on bottom. So how am I going to undo dividing by x? Well, I'm going to multiply. So if I want to undo dividing by x, this x is going to multiply up to the 12. And if I want to undo dividing by 15 on the right-hand side, this 15 is going to multiply up to the 8. And we call this property that we're using the cross product property. We'll come back and solve the one I just talked about in a second, but right now we're going to discuss the property. Cross product property allows me to solve any proportion. It will work on the ones that we did prior, but it involves a little bit more steps than just simply looking for a pattern. So if I have A over B equals C over D, if I undo dividing by D and multiply by D, I get A times D. If I undo dividing by B and multiply by B, I then get equals B times C, and I can then solve from there. So that's what the cross product property is. Recall though, the cross product property is only a tool to solve proportions. It is not used to multiply fractions. Okay? Example, well, let's use it here. If I want to undo dividing by x, I would multiply both sides by x, and I would get then 12 times x. On the right hand side, if I want to undo dividing by 15, I multiply by 15. 8 times 15 is going to be 120. And then I can solve by dividing by both sides by 12. So then I get 10. 10 is my answer. If I put 10 back in there, I will see that those two ratios are equal to one another. Okay, second one. If I have this one, this is kind of a more involved one, I can use my cross product property again. How do I undo dividing by x? Well, I'll multiply the x up to the other side and get 8x. How do I undo multiplying or dividing by x minus 3? Well, I'm going to multiply by x minus 3, and I need to communicate that 4 is multiplying all of x minus 3, so I put parentheses around it. Now I just need to solve. This is why we reviewed solving equations a few days ago. I simplify, which is distribute, so multiply the 4 through, and I get 4x minus 12. 8x is just hanging out. Okay. Now I need to get same side. I need to get my variables to the same side, so I'm going to subtract 4x from each side. So all of my variables will be on the right-hand side. I then get negative 12 equals 8x minus 4x is another 4x. Now I need to solve. My last step is going to be divide by 4, and I get my final answer of negative 3. So negative 3 is my answer. Okay, and I'm using the cross product property. I'm going to give you a chance to try. So pull out your whiteboard, and then on your whiteboard I'm going to put another example or question up, and I'm going to have you try it. So on the whiteboard, your task is to try this question. Can you solve for x using the cross product property? You're going to undo dividing by 15. You're going to multiply this 15 up here. You're going to undo dividing by 10 and multiply the 10 out to the other side. So give you maybe pause the video for a minute and a half. Once everyone's had a minute and a half to try it and check with a neighbor, I will talk our way through it. So pause the video now, please. Okay, welcome back. The answer you should get is 0.8 or 4/5. I'll show how we get that. So I need to undo dividing by 15 and multiply the 15 up to the other side. I'll then get 15 times the quantity 6x plus 2. Then I need to undo dividing by 10 and multiply the 10 up to the other side. And I get 10 times the quantity 4x plus 7. Now I need to distribute first, simplify. When I distribute the 10, I'm going to get 40x plus 70. When I distribute the 15, I'm going to get, was that 90? 90x plus 30. I need to get my variables to the same side, so I subtract 40x from each side. So I have no more variables on the left, and I get then 50x plus 30. I need to get my number terms to the same side, so I subtract 30 from the right, so they're all on the left. 70 minus 30 makes 50, and I get 40 equals 50x. Last step is to solve. Undo what's happening to x, divide by 50. 40 divided by 50 is my 0.8x, or you can write it as 4/5. Okay, there you go. That's all of 2.6. If you would, please flip your page. We're going to talk about what goes on in 2.7, which is just a brief review of percents. So as you're flipping the page, you'll see at the top of the page for 2.7, I discuss 4 examples of where percents get used in everyday life. One of them is down payment on a car. Second one is determining defective items. If you work for a company, you need to make sure that your company is meeting the industry standard for how many items are defective in a batch. Other places are pay raises or even taxes. So in some states, you have to pay in sales tax. In Montana, we don't, but the majority of states do. So we need to be able to work with percents. If we're going to be working with percents, we should probably know what the word percent means. The word percent is actually directions. It has 2 parts to it. The word per means divide. Like if I say miles per hour, I mean miles divided by hours. So per means divide, and then cent means 100. Like if I ask you how many cents are in a dollar, you say 100. How many years are in a century? 100. How many feet does a centipede have? 100. So the word percent is actually directions. It's telling the person to divide by 100. That's what percent means. Because of that, I can then set a percent question up as a proportion. Here's an example. So I'm going to give you 2 strategies down below in your notes. One of them is called the proportion method and one is called the equation method. Once I've shown both, it's your call which one you want to use, but I'm going to show the proportion method first. So this enables you to answer a question like what percent of 25 is 17? When I set up the proportion method, here is my template. I put percent being divided by 100 because that's what percent means. Is on top and of is down below. Is the portion, so that's the up top part. Of is the total, so that's the down below part. Then I just plug the pieces in. What percent? I don't know what percent, so I'm going to put X in the percent location. It says of 25, so I put 25 in the of location, and is 17, so I put 17 in the is location. I can then use cross products to solve, so if I want to, I can use cross products and go this way, or I can actually just simply look for a pattern. In this case, the pattern's not too bad. How do I go from 25 to 100? I multiply by 4, so the same thing must be true here. I'm going to multiply by 4, and if I do 17 times 4, I'm going to get 68. So 17 is 68% of 25. So there's example number 1. Example number 2 looks like this. What number is 25% of 88? So I pick out the pieces I can. I see 25%. That's the part that's being divided by 100. So I put 25 divided by 100. Of 88, so that's the total. And it says what number is, I don't know the is, so I put X. Again, I could use cross product property if I want to, undo dividing by 88 by multiply by 88, multiply the 100 up to the X, or I can simply look for a pattern. There's a pretty easy pattern here. To go from 100 to 25, I can divide by 4, so I'm going to look for a same pattern over here. Divide by 4. 88 divided by 4 is 22. That's why 22 is a quarter, or 25% of 88. So my answer is 22. That is an example of using the proportion method. The proportion method is kind of a beginner's method, but some people really like it and stick with it. So I'll show you the second method, which is actually, I think, makes a little bit more sense and is a little bit more flexible and intuitive. So what we're going to be using is what's known as the percent equation. It's simply a translation. So I'm going to translate the sentence, A is P% of B. A is just the letter A. Okay, the next part we have to translate is. In math, is means equals. If I say 2 plus 5 is 7, we mean 2 plus 5 equals 7. Then we have P. P is a percent, and because it's a percent in an equation, we need to always make sure that this has to be a decimal. So make a note of that in your notes, that this has to be a decimal. Then we need to translate the word of. Of in math means multiply. If I say 3 groups of 5 people are going to the movies, 3 times 5 is 15. So of means multiply, and then the letter B is B. So we're just translating to an equation. Here's an example of it actually being used for a problem. If I ask the question, what is 30% of 50? Let's translate. What? I don't know, so we use X in math if I don't know. Is means equals. Like 2 plus 2 is 4. 2 plus 2 equals 4. 30%. I need to write it as a decimal. 30% as a decimal is 30 divided by 100 is 0.3. Of means multiply, so I put a little times there. 50 is just the number 50. So if I want 30% of 50, I just need to do 0.3 times 50, and that's going to give me 15. So 15 is 30% of 50. Second example. 35 is, well, I'll go back, give people a chance to make sure you got it. So 0.3 times 50. 30% is 0.3, of is times 50, 50. 0.3 times 50 is 15. Second example. 35 is what percent of 105? 35 is a number 35. Is means equals. What percent? I don't know, so I put an X. Of means times 105. How do I solve? I need to undo multiply by 105. I divide by 105, and when I do that, I'm going to get a third. 0.33 is equal to X. If I want to write it actually out as a percent, I would say 33.3 repeating. That is the percentage. Or you can leave it as a decimal. Okay? So you can translate to a percent or set it up as a proportion. Now I'm going to ask you to try. So the last one on the whiteboards today. So please have your whiteboard out. And I want you to try to answer this question. 24 is 80% of what? You can either use the proportion method or the equation method. It doesn't matter to me. So pause the video now for just a minute. Shouldn't take more than a minute. Give it a go, check with your neighbor, and then come back after a minute, please. Okay, welcome back. Let's do the translation first. It says 24 is for proportion. 80% is the part being divided by 100, so 80 goes here. Of what? I don't know, so X goes down here. If I solve, I would do 80 times X, gives me 80X. And then do 100 times 24 is 2400. And then if I divide both sides by 80, I get my answer, which would be 30. If I do the equation method, I would need to translate 24 means equals 80% is 0.8 of is multiply what I don't know is x. I need to divide both sides by 0.8. If I divide both sides by 0.8, I'm going to get the same answer of 30. So 24 is 80% of 30. Either way works. You just use whichever one is more natural to you. Last part is just some practice translating. So we talked about some applications in real life. You should be able to translate them so you could solve. So here's the first situation. You're looking to buy a car. Whenever you go to buy a car, the dealer requires that you put a certain percent down. Let's say you need to put 15% down. If that 15% is $2,700, what's the total cost of the car? So if you translate, it would be this. $2,700 is 15% of what number? Then it'd be up to you to solve the rest. But right now we're just going to practice translating. So the translation would be this. 2,700 is 15% of what number? I think it turns out the answer is going to be $18,000 is the total cost of the car. But I'll let you get the in-between part, the translation, after it. Example number 2, let's say a worker earns $28.50 per hour. If she receives a pay raise of 7.5%, how much does she earn per hour now? If I translate the first part of the question, it would look like this. 7.5% of $28.50 is what number? That's the part you need to be able to translate to so that you can then work it mathematically. So once you translate to English, if you translate to math, you're going to get an answer of $2.14, I believe. But the final question is, how much does she earn per hour now? So I need to add that to the $28.50, and the final answer is $30.64. I'll let you fill in the steps in between, because right now the bigger point is just practice translating. Okay. Last part is just a vocab word that the homework assumes you know, so we're going to mention it right now. It's called percent of change. Percent of change is the ratio of the change to the original amount, expressed as a percent. I wouldn't write down the definition. I would simply write down this equation right here. So the percent of change equation is change divided by original times 100%. So I would write down that equation. Also note that change is always equal to new minus original. Okay? Once you have that down, here's an example of a problem. If a worker originally made $45,000 a year and now makes $48,000 a year, what was his percent of change? Well, the first thing I need to do is calculate change. Change is 48,000, because that's the new, minus 45,000, which is the old. So 3,000 is the change. Now I can use my percent of change equation. The percent of change is going to be the change, which is $30,000. It's positive, so it's an increase compared to the original, which is 45,000, times 100%. When I do that, I see it's 6.66%. We'll see it's 6.66%. That's the percent of change. Okay, so percent of change is always change divided by original times 100%, so we can get it as a percentage. If your change is positive, it means you're increasing. If your change is negative, it would mean it's a decrease. Okay, that is it for 2.6 and 2.7. The rest of the time is for you to try the homework questions. I will show the answers to 2.6 right here. I can't show all of 2.6 and 2.7. They're actually 2 pages in my file, so you can check them individually on your own if you get to my class website, or you just flip to the back of the book. And then when I'm back, I will check both assignments of 2.5 and then today's assignment. So that's it. Have any questions ready for me? Make sure you're working on the boot camp so you don't save it for the last night. And then I will see you when I get back. Thank you very much and have a good day.